It's day 57. We're going to be tackling a concept today called recursion. So just what is recursion? Well, recursion is a type of programming where we get a subroutine to call itself. And that sounds a bit confusing because we do run the risk of entering into an infinite loop. That's a problem. But it does allow us to solve problems in a more human way. And I'll give you a great example of this. Okay, let's imagine that we want to print out numbers counting backwards by an arbitrary value. Let's say 2, for instance. Now, I'm sure already you're thinking, hold on, I could use the range function for that. And you could, but the way in which the range function is coded is very interesting when it counts backwards, because recursion allows us to write this program in a very similar way to the way we'd think about it. Let's try it out. So I want a program that I can give a number to and will print out a number of blocks counting backwards in 2 each time. So if I'm starting out with 5, it should print out 5 blocks. On the next line, it should print out 3 blocks. On the next line, it should print out 1 block. And on the next line, nothing. Now, that can be written in a loop, but a loop is going to be reasonably long and quite complicated for this project. If we write a recursive function, we're going to say print out 5 and then print out 3. And the 3 function is going to say print out 3 and then do it again with 1. Let's see how that's going to work. So I'm going to start out by defining a function called reverse that takes in a value of the number. And that's going to be the number of things that are going to be printed out. So let's start with an if statement, because the thing about a recursive function is there needs to be an ending condition. When we get a subroutine to call itself, if there's no point at which the subroutine can stop, then it will just keep calling itself forever. So let's deal with that first. Let's do if value is less than or equal to 0. Well, what are we going to do if we've hit the bottom? Well, we're going to print out something like done, and we're going to return to the main body of the program. Otherwise, what we're going to do is we're going to loop for every number in value, and we're going to print out that many symbols. So let's pick an emoji to put in here. Let's go for the 100 days. And I'm going to add end equals blank to that because I don't want it to go weird. Once that's done, I want to print out a new line character to get it on the next line. And I'm going to call itself with value -2. So what's going to happen now is that when I call reverse with any number, it's going to start out by checking to see if that number is less than or equal to 0. If it is, it's just going to print out done and stop. If it's not, it's going to print out that many symbols, and then it's going to call itself with a smaller number. Let's start that off with 5, our example. There we go. We start with 5, then 3, then 1. And all this is being accomplished by the program calling itself. Now, the nice bit about this is that I can go for any number here and should get the same effect, which is quite nice. And of course, I can change that number to be whatever I want if I want to print out single values, and I'm printing out nice graphics in an interesting way backwards by calling itself. Now you might be thinking this far, what's the point of a recursive function? I could do that with a loop. And you know what? Yes, absolutely. But recursion is an important concept in programming because some problems can be solved better with recursion than they can with loops and iteration. Many of these problems are mathematical in nature, so you might think, I'm probably not going to use much of that. But it's a nice thing to know about, because sometimes you've got an idea in your head which is just do that again with a different number. And that's where iteration comes in. Stop there, try and build my program and have a fiddle around with it and see what you can do. Common problems. Well, when you're dealing with recursion, it is a very difficult concept to think about, and therefore you can make a lot of mistakes. One of the key problems can be not having an ending condition. If I accidentally strip out the ending condition of this subroutine, so now there's no way of telling it to stop, when I run it, you'll see that eventually it just crashes. Now, if we scroll up, you can see that it actually has been printing out the numbers, but then has been printing out a negative value. And it's actually happened there until I've eaten up all the resources on the machine and it's just died. Now the problem with that is when you use recursion, you're basically saying to the REPL, you're saying, okay, right, stop what you're doing, go and make a copy of myself and run that. And that's saying, okay, stop what I'm doing, make a copy of myself and run that. And what's happening is the RAM is being eaten up. In fact, we can probably see that if we run it here. And I'll just change the way it's working so it's running the opposite way so it'll run longer. Can you see here my RAM climbing up? Now it's going slow because I'm dealing with text here, but the RAM is climbing up because it is calling copies of itself and therefore it needs to be stored somewhere. Now luckily Python has a limit to the amount of recursion that can be included. When we're calling a function by itself, it will stop eventually. If it didn't, that would run out of control until all the RAM on the REPL or all the RAM on the computer was taken up by the function and it would then crash. This is a major problem. So we always have to make sure that we have an ending condition built in. Your challenge today is to try and use recursion to build a program that calculates the factorial of any number. This is a very mathsy question, so let's try and explain what a factorial is. The factorial is the product of all the numbers that come before that value. So factorial 5 is going to be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Factorial 10 is going to be 10 multiplied by 9 multiplied by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1 and so on. It is a fantastic problem to solve with recursion because you need to start at the highest number which multiplies itself by factorial of itself minus 1, calling the function again and making it recursive. Write a function that starts with the highest number and multiplies itself by a call to itself minus 1. There will need to be a terminating condition when it reaches 1 and it just returns 1 at that point, and up the stack should pop and your answer should be sorted. I totally understand if this one is leaving you scratching your head a little bit. So have a look in the written content and see if there are some starting points of code and some spoilers that you can start with. Or hop into my answer for this question, which will be in the last page of the tutorial. If you need support, you're welcome to come to Replit 101, which is our live session, which happens every other Wednesday. Or you can post a comment in ask.replit.com under the 100 Days of Code section, or jump on the Discord and ask people there. When you're done, please publish it in the community and share it on social media with the hashtag Replit 100 Days of Code. Tomorrow we'll be looking at the debugger because it is quite hard to do recursion, so knowing how to use the debugger is probably worthwhile.